MCV4U1 Chapter 2, Session 7. In this chapter, we work on Section 2.3 of the textbook, which is the product rule. If P at x equals f of x times g of x, P prime of x is f prime of x g of x plus f of x g prime of x. In words, the product rule says the derivative of the product of two functions is equal to the derivative of the first function times the second function plus the first function times derivative of the second function. Let's quickly go over the proof of the product rule. P prime of x is limit of f of x plus h times g of x plus h minus f of x times g of x over h as h approaches 0. To find this limit, we add minus f of x g of x plus h and subtract the same term, and split the limits by factoring g of x plus h between the first two terms and f of x between the last two terms. Using the properties of the limit, this limit would be limit of f of x plus h minus f of x over h times g of x plus h plus limit of f of x times g of x plus h minus g of x over h. The limit of addition is addition of limits. Then we use the fact that the limit of product is product of the limits and use the definition of limits and substitute f prime of x instead of limit of f of x plus h minus f of x over h, and similar term for g of x. Let's find the derivative of h of x equals x2 minus 3x times x5 plus 2. This is the product of two functions. The derivative would be derivative of x2 minus 3x times x5 plus 2 plus derivative of x5 plus 2 times x2 minus 3x. Derivative of x2 minus 3x is 2x minus 3, and derivative of x5 plus 2 is 5x4. By algebraic manipulation, the final answer would be 7x6 minus 18x5 plus 4x minus 6. Let's find h prime of negative 1 when h of x is 5x3 plus 7x2 plus 3 times 2x2 plus x plus 6. We know h prime of x is derivative of the first function, which is 15x2 plus 14x, times the second function itself, plus derivative of the second function, derivative of 2x2 plus x plus 6, which is 4x plus 1 times the first function, 5x3 plus 7x2 plus 3. Then we replace x by negative 1 and we find the derivative. If the function contains the product of, if the function is product of more than two functions, we can use associative law and find the derivative. For example, for three functions, if p at x equals f of x times g of x times h of x, we write it as f of x times g of x times h of x. Then we apply the product rule for two functions, derivative of the first function times h of x, plus first function, which is f of x times g of x times h prime of x. We use the fact that the derivative of f of x times g of x is f prime of x, g of x, plus f of x times g prime of x, and we expand and simplify it. This is extension to product rule. It can be done for n functions similarly. If a function is power of another function, we use the idea of multiplication of the function n times, and we apply the extension of product rule. Let's find the derivative of h of x equals g of x to the power of 3. G of x to the power of 3 is g of x times g of x times g of x. The derivative of h of x would be g prime of x times g of x times g of x, plus g of x times g prime of x times g of x, plus g of x times g of x times g prime of x, which is 3 g of x to the power of 2 g prime of x. Same way, we can prove the derivative of g of x to the power of n is n g of x to the power of n minus 1 times g prime of x. Using Leibniz notation, we say derivative of un with respect to x is n u to the power of n minus 1 du dx, when u is a function of x. Let's find h prime of x when h of x is x2 plus 3x plus 5 to the power of 6. In this case, g of x is x2 plus 3x plus 5. To find the derivative, we use the fact that derivative of g of x to the power of 6 is 6 g of x to the power of 5 times g prime of x. 6 g of x to the power of 5 times g prime of x. Let's find the derivative of f of x equals 2x plus 5 over 3x minus 1. F of x can be written as 2x plus 5 times 3x minus 1 to the power of negative 1. We use product rule and find the derivative of the product of two functions. Derivative of the first function is 2, and derivative of the second function, 3x minus 1 to the power of 2, is minus 1 times 3x minus 1 to the power of minus 2 times 3. If we apply the product rule, this derivative would be 2 times 3x minus 1 to the power of negative 1 plus 2x plus 5 times negative 1, 3x minus 1 to the power of negative 2 times 3. Then we convert the negative exponents to positive and take the common denominator and simplify it. Generally speaking, if a function is in the form of f of x divided by g of x, if we write the function as f of x times g of x to the power of negative 1 and apply the product rule and the power rule, the derivative would be f prime of x times g of x minus g prime of x times f of x divided by g of x to the power of 2. This is called quotient rule. Next example. The position s in centimeters of an object moving in a straight line is given by s equals t times 6 minus 3t to the power of 4, where t is the time in second and s is the displacement in centimeter as it is mentioned previously. Determine the object's velocity at t equals 2. We know velocity is the derivative of the position function. So we need the derivative of t times 6 minus 3t to the power of 4. Derivative of first is t, derivative is 1, times second function 6 minus 3t to the power of 4, times first function times derivative of 6 minus 3t to the power of 4. Derivative of 6 minus 3t to the power of 4, 6 minus 3t to the power of 4 is 4 times 6 minus 3t to the power of 3 times negative 3. Then by replacing 2 into the derivative, we see velocity is 0. Therefore, the object is at rest at t equals 2. Let's recap. The product rule, derivative of h of x equals f of x times g of x is h prime of x equals f prime of x g of x plus f of x g prime of x. Power rule, derivative of g of x to the power of n is n g of x times n g of x to the power of n minus 1 times g prime of x. And quotient rule, the derivative of f of x over g of x is f prime of x g of x minus g prime of x f of x divided by g of x to the power of 2. To understand this concept better, work on the following questions in exercise 2.3. Question number 1, part D and F. Question number 9. Question number 10. Question number 11. Question number 13 and 14. Thanks for watching.